Hello, everyone. This is the M3T1 review. This is for the exponential review that we're going to be having. So it's going to cover 6 different things. So be ready. Again, do not do all of them. Do not listen to me the whole entire time. Pause me. Try the problems yourself. And then if you have a question, then come back to this again. All right. Here we go. Problem number 1. We're going to be simplifying radicals. So from problems number 1 through 6, simplifying radicals. First step, break it down. We're going to do get to some prime factorization. Basically, we're making everything into prime numbers. So 80, what goes into 80? 8 times 10, right? So we're going to go 8 and 10, just like that. And we're going to keep on breaking it down until we get to like just prime numbers. What are prime numbers? Numbers that cannot be divisible by any other number except for 1 in itself. All right, so 8 can be broken down into 2 and 4. Again, if you started out instead of 8 and 10, you said 2 and 40, that totally works. Okay. Either way you start, you're going to end up with the same numbers. So 4 can be broken down into 2 times 2, not 2 plus 2, 2 times 2. What can be broken down into 10? Not 5 and 5, 5 times 2. All right, so I think everything here is a prime. Not I think, I know. The 2, we got all 2s and 5s. So we're saying that the square root of 8, we're going to rewrite the square root of 80 as 2 times 2 times 2 times 5 times 2. So basically, how many 2's do we have? I got 4 of them. 1, 2, 3, 4 times 5. I'm just going to extend that radical. All right, so basically 80 is the same thing as 2 times 2 times 2 times 2 times 5. How do I know that? Well, what's 2 times 2? 4. 4 times 2? 8. 8 times 2? 16. 16 times 5? 80. Okay. So what are we going to do now? We're going to look for perfect squares. Okay, perfect squares is going to help us simplify these radicals. So I have a perfect square here. I'm going to use different colors here. So I have a perfect square right here, 2 times 2, which we could rewrite as square root of 4. And I have another one, this 2 times 2. It's another pair right here. And that could be written as square root of 4 as well. And then my leftovers, so I just have this 5 here, so it's going to still, again, square root of 5. And again, I'm just rewriting this. 4 times 4 is 16, which again, times 5 is 80. Okay. So again, I'm just rewriting it. I'm not making square root of 80 into anything else. Okay, so then we got, what is square root of 4? This is an important part. Square root of 4 is just 2, because 2 times 2 is 4. Right here, again, our square root of 4 is, I think I use this color. My square root of 4 is 2. And then the square root of 5, it's not a perfect square, so we're going to just leave it just like that. Okay? And then we're going to just simplify this out. We know what 2 times 2 is. 2 times 2 is just 4, so it's going to be 4 root 5. That's it. So if in your calculator you punch in square root of 80, and then you also punch in 4 root 5, you're going to get the same number. Okay, this just looks different front. We're simplifying. We're not solving for anything, just simplifying. Okay, we're going to do the same thing for number 2. And again, break this up. What goes into 196? Let's say, I know 2 for sure, right? So 2 goes into 196 9 times, with a remainder of 1. So 2 goes into 16 8 times, so 98 times. So 2 times 98, I know I can break up the 98 with 2. So 2 goes into 98 4 times. So 2 goes into 9 4 times with a remainder of 1. 2 goes into 18 9 times. Ooh, 49. I know that one. That one is 7 and 7. Okay. I'm showing you the long way. If you find a shortcut, make sure it works for every single time. But yeah, you could totally do shortcuts here, but I'm not going to show you them. All right, you're going to figure that out yourself. Okay, so 2 times 2 times 7 times 7. All those are prime numbers, so I'm just going to rewrite that. So we got 2 times 2 times 7 times 7. And you'd be like, wait, I have 2 2's, right? So we know that we could write that as square root of 4. And I have 2 7's. I could write that as square root of 49. Okay, and then what is square root of 4? Ooh. Oh, and notice there's nothing else in the square because we took up all the numbers. And what is the square root of 49? 7. Why 7? Because 7 times 7 is 49. And then our answer is just going to be that multiplied. So 2 times 7 is going to be 14. So we notice right here we don't have any square root in there. Why? Because actually 196 is a perfect square. Okay, it's literally 14 times 14, which is 196. All right, number 3. Okay, so here we go. We got 28. Again, break it up. So I need to know your times tables really well. We know that 4 times 7 is going to be 28, and 4 times 4 is, oh no, 2 times 2 is 4. And now I have, again, is all my prime numbers here. So 2 times 2 times 7. Again, order does not matter as long as you have all of these ones. Why are we not putting in the 4? Because we already have the 4 represented as this 2 times 2. Okie dokes. So here we go. I got my pair right here. So I know that's going to be square root of 4. And then my 7 is just by itself. So I'm just going to copy that down, square root of 7. And what is my square root of 4? It's just 2. And my square root of 7 is not a perfect square, so we're going to leave that as the square root of 7. So my answer is just going to be 2 root 7. Okay. All right. We'll keep on going. 28. Well, I know 3 times 9 is 28. Oh, I meant 27. I saw 28 in it. Anyways, so 3 times 9 is 27. I could break down the 9 into 3 times 3. So look right here. I got 3 3s. So I'm going to just rewrite it here. So 3 times 3 times 3. Do I got a pair of 3s? I sure do. So I got that. So that's going to be square root of 9. My other 3, I don't have a pair for, so I'm just going to rewrite that as square root of 3. And then square root of 9, what is that? 3. And then my square root of 3 that I cannot simplify. There we go. Nothing else to it. Yay. All right, 150. Okay. We can do 150. Ooh, this ends in a 0, so I know I could break it down to 15, and 10. And then 15 can be broken down into 3 and 5. And 10 can be broken down to 2 and 5. All right, so I know that I can rewrite this as, I'm going to get my doubles first. So I have 2 5s, and then I have a 3, and then I have a 2. All right, 4 of those guys right there. And yep, I got my pair. You may be wondering, what if we have no pair? What do we do? If there's no pairs, then this cannot be simplified anymore. You just be like square root of 150. That's it. Okay, but this one does have a pair, so we can actually rewrite that as square root of 25. And then the rest of them have no pairs. So since they're already multiplying, we're going to just go 3 times 2, which is 6. So whatever are singles, if you have more than one number, you're just going to multiply them back together again. So that would just be your 6 right here. And what's your square root of 25? That would be 5. And we would just bring down that square root of 6 because square root of 6 is not a perfect square. Just like that. All right, 32. Breaking this down, we got 8 and 4. 8 times 4 is 32. You could also, 8 can be broken down to 2 and 4. 4 can be broken down into 2 and 2. 4 is going to be 2 and 2. Okay, so now we have all these 2's going on here. How many 2's do we have? 1, 2, 3, 4, 5. So we're going to be like 2 times 2 times 2 times 2 times 2, which is equal to 32. Now we're going to look for our groups of 2. There's our first one, which is going to be our square root of 4. Our second one is going to be our square root of 4 again. And we have 1 left over. That's going to be just our square root of 2. And then let's go. Square root of 4 is 2. And what is the square root of 4 again? Still 2. I'm putting the dot there to remind myself that I need to multiply. And then we just bring down our square root of 2, this one right here, because it's not a perfect square. And we're almost done there. So this 2 times 2, which is both outside of the radical, It's going to be 4 root 2. Done. Okay. That's all for radicals. Please make sure you're practicing. Try other numbers, right? And then all you need to do is check on your calculator, see if they're the same, because they should be the same if you did it correctly. All right. So we're writing the next 7 through 10 as well as 11 through 14 are literally the same thing, but backwards. So first thing I need to show you, like I showed you in class, if we're going to call this, actually, let me do it this way. We're going to say radical. Okay, so what is the radical form? So this is a radical right here. This shape is the radical, not shape. The symbol is a radical. And inside is what we call the radicand. And we're going to have an exponent that goes up here. And then there's sometimes a number here, and that's going to be our I. Okay, that looked like a weird one. I. A little bit better. So in the radical form, we have a radical. So if we have exponential form, we're going to have exponents. I know we kind of have one here, but it's only going to be exponents. So we can rewrite that as E over I. Okay, that's as far as I'm going to go into. I'm not going to go into the Y or all that kind of stuff because we did that in class. I'm just telling you, this is what it is. All we're doing is just rewriting them. We're rearranging some of these numbers, okay? So here we have exponential form, right? The one looks like the one on the right. We want to make it in radical form, it says, right? So the one on the left. So what do? So I'm going to make my radical right here like this. And the big number, see this R is like that 4 right here. So we're going to put that 4. By big number, I don't mean like the most amount, but like the size of it is big, right? So that's the 4 right there. And then our exponent right here is the one on top of the fraction. So we're going to look at that and it's going to be like, oh, it's a 1. And then the bottom number is that index. So we're going to put that little in the nook right here, 3. Do not make it big. It will be wrong. Okay. So because this means something completely different. Like this means 3 times the square root of 4. Just like what we were doing like up here with 4 root 2. But this means the cube root of 4, which is something different. Okay, so don't do this. This is bad days. I'm just going to erase that. So, okay, so now moving on. So notice that this is to the first power. You could also just say, if you want to be fancy like that, just like this, because this assumes that if there's no exponent here, we just know it's a 1, right? Because how many 4s are there? There's just 1. Not 0. We wouldn't say 0 because there is a 4. It's right there. Okay, so that's it. This is the better answer, but the one on the left, that's also fine. Totally good. Okay, you will not be marked off for that. Okay, same thing with this one. So we want a radical form. So here's our big number here is 5. Our exponent is 3. And our little nook, our index is going to be 4. So it's the 4th root of 5 cubed. Easy, right? It's not terrible. Yeah, you better pause. Keep going. Try it yourself. So 7 to the exponent of 3 and then 2. Again, this one, we can write it a little bit better because if we actually, you'll notice a lot of times we don't have a number there. You've probably never seen it with a number, which means that it's just a square root, right? A square root means what? Square means 2, right? Because like what's 2 squared? Or I should say 3 squared, 3 times 3, right? So we're doing that twice. So square root. So this, if there's nothing there, it actually means just 2. So we know the index is 2, so we would just go like this. So again, cross my 7. So this is the better answer, but also the correct answer is the one on the left. Either one totally works, but the one on the right is more professional, right? And then, okay, last one. We got 10 to the power of 5, and then 6 root right there. All right, that's it. Okay, we're going to go on to the next one. Notice, actually, let's see if I could take, no, I thought I could take it, but I guess I can't. We're going to do the same thing here. I guess I'll just do it on the bottom. So this is in radical form. So we're going to change to exponential form. So we're going from the left to the right. So again, the R, same thing. So the big number here is 6. And what's my power? 5, right? And then what's my index? See, do you see how there's no number there? What does that mean? Yeah, it's a 2. Okay, this is it. Make sure you're writing your exponent. This is hard for a lot of kids. It needs to be up and smaller. Okay, please do not do that. This is not exponents, peoples. This is 6 and 5 halves. This is bad days. Okay, you do not want that. You may make it up like this, and up and smaller. All right, let's try this number 12. Again, 10 to the 3 over 2. Since there's no index, we know that there's a 2. This is a square root. All right, same thing with this one. We got 10 to the power of 6 over 5. Remember, roots go on the bottom, so the index goes on the bottom, because you know what? It's like trees. Roots, where are the roots? On the bottom. They're not at the top, because that would be weird. All right, we're going to go again, 3, and then we got to the 2 over 3. So 3 to the 2/3 power. That's how we would say that. All right, done. Now we're going to go to exponents. Again, if you don't know, if you've not learned the exponent properties, go to that other video, okay, that talks about exponent properties. All right, so here we go. We're just going to simplify. We're going to leave it in exponent form. We're not like actually calculating this out. Like we're not going to do 3 times 3 squared in our calculator and be like, oh, 27. No, that's not what I want. We're just looking at just exponent properties. So we're going to be like, okay, there's 1 3 here, and 3 squared means what? There are 2 3s that are multiplied. So including this one over here. So let me see if I could like highlight it. So this is that. And we have this right here is these 2 guys right here. See how that works? So how many 3s are we actually multiplying together? We have 3 3s, so 3 to the 3rd power. Done. That's it, right? Did you see the shortcut way? All right, remember if I said that there was no exponent, you're just going to be like, okay, again, on the test, if you're like, I don't remember what the rule is, you don't need to remember. Just think about it logically. What does it mean? What does 4 to the 4th power mean? 4 times 4 times 4 times 4, right? You got 4 of these 4s going on, right? That's your first one. That's this guy right here. What is the second one? It says times 4 to the 3rd power. Well, what does that mean? 4 times 4 times 4, right? This is critical thinking, peoples. We're like, well, what does it mean, peoples? All right, and then let's try the last one. Let's make that purple. Again, this is 4 to the 4th power. 1, 2, 3, 4. Do you see any divide here? No, they were just multiplying all the way across. So how many 4s do we have? We have 4 here plus 3 plus 2, 4 more. So that's actually equal to what? 4 to, actually I didn't add that up. That's going to be 8, 11. So there's going to be 11 4s. So it's 4 to the 11th power. Done. All right, so we got 4 squared. We're gonna do this again. Do you see the? So you could potentially in your head you could be like, oh, because do you need to always expand this out? No. So you'd be like 4 squared. Okay, I got 2 of them there. I have 4 cubed here, so that means I have 3 there. So 2 plus 3. So this is just 4 to the 5th power. That simple. You see, like you just don't even need to. Okay, 4 to the 0 power. You better know this. You better not say 0. It's not 0. When it's not 4, what is it? Anything to 0 power is this right here. See? 1. All right, 2 to the... Okay, this is a silly question. I'm sorry. I thought I erased this one, but apparently I did not. I apologize. Just 2 to the 4th power is just going to be 2 to the 4th power. Nothing for us to do. Just now I'm curious what the answer is. Okay, go look at 19. I'm going to look at 19 because I'm curious now. Okay, it's upside down, but yeah, see, 2 to the 4th power. If I turn your phone upside down, very carefully because it'll flip over again. Yep, 2 to the 4th power. There's nothing to simplify. So we're just going to leave it like that. That's a silly question. I'm sorry. That was, anyways, we're just going to go with that. All right, so here, let's go to 20. Okay, so again, what does this mean? So what does these mean? Okay, 2 squared, we have 2 squared, but how many times do we have, are we multiplying that? We're multiplying that 4 times. So we're going to do this 1, 2, 3, 4. So we have it 4 times just like how it says up here. So remember, go back to, this is basically what we're doing here, right? We have two twos here, another two twos here, and another. Okay, so we actually have how many twos? 2, 4, 6, 8. We're going to have 2 to the 8th power. That's it. 2 to the 8th power. All right, let's do number 21. Just gonna logically reason this out. I'm like, I don't remember the rule. Do you remember the rule? Yeah, I do remember the rule, but I'm not telling you. There's 4 3s on the bottom. I do this long enough, and you just take a look at it long enough, you'll be like, oh yeah, that's the rule. Okay. All right. So once we expanded it, we got 2 3s up here and 4 3s on the bottom, and then we're like, okay, we got to make this simpler, right? We can cancel a few things out because what's 3 divided by 3? It's just 1, right? So I'm going to do this in a different color. So we're like, okay, I know this is just equal to 1, and this 3 is also equal to 1, right? Remember, we're just multiplying these guys. So what's left on top? Don't say 0. We have 1 times 1, which is 1 over, well, 3 squared. We got 2 3s, right? I know you want to say 9. Okay, if you wrote a 9, I wouldn't be too mad, but just write 3 squared. Leave it as the exponent because what we're trying to practice here is practicing our exponent properties. Okay, that's what we're doing. I'm not trying to see, oh, do you know what 3 squared is? Is it 9? Did you know that? Yeah, I'm not doing that. Okay, we're doing this one right here. So again, we have how many 2's on top? 3 2's on the top. And how many on the bottom? 1. So then how many can we cancel out? This one right here. So how many do we have left? Where is it located? On the top. You notice it's on the top. Over here at 21, it was on the bottom because that's where the 3's were. So you need to have a fraction bar there. Here we don't have to have a fraction bar because what's left on the bottom is just a 1, right? What's 2 to the 4th divided by 1? Or 2 to the squared divided by 1? It's just 2 squared. All right, we're going to keep on going. You may have noticed, here we're going to try this in our heads. We have how many 3's on the top? We have 4. How many 3's do we have on the bottom? We have 2. How many can we cancel out? 2, right? How many do we have left? 2 of them. Where are they located? On the top. Let's do it with your fingers, right? So we got 3 squared. That's it. Some of you guys may be like, oh, wait, isn't that just like subtracting? I'm like, yeah, because we have 4 of them on top, 2 on the bottom. We take out those 2, and what do you have left? Just a 2. So 3 squared right here. 2 minus 4 would be 3 to the negative 2. But we would have had to change to this anyways. But anyways, again, right here, we got 4 2's, and we got 4 2's here. So we got how many altogether? 2 to the 8th power. 4 plus 4, 8. All right. Okay. This one is an interesting one. So remember this one right here. It does have an exponent. If there's no exponent, what is the exponent? 1, because there's one of them there, right? So if we're going to use our rule here, 1 plus negative 2 is negative 3 to the negative 1. Ooh. But I don't know if you noticed, but up here it says your answer should only contain positive exponents. That's not a positive exponent. That's negative. So what should you do? Got to change it. So we're going to change that to 1 over negative 3. Or we could just say we don't have normally negatives on the bottom. So negative 1/3 would be your answer. And if you're like, honestly, I didn't get that. So I would try this one time. I'll do it in a different color. We'll do it in green. So we got our negative 3, right? Times. Remember, our negative exponent brings it to the bottom. So we're going to be like negative 3 on the bottom. And we have that squared. What's left on top? Just a 1. Okay, so then what are we going to do? We're going to be like, well, negative 3 times 1 is negative 3 over negative 3 squared. Well, how many negative 3's can I, cancel out? I can cancel out 1. Okay, let me just rewrite this so you can see it. So we have 2 negative 3's, right? So how many of those can I cancel? I can cancel out 1, which leaves me a 1 on top. So what's that going to equal? 1 over negative 3. See? Either way you want to do this, there's many different ways, many pathways to get to this place. All right, so then again, we're going to just not have the negative on the bottom. We're going to just write it on the side, negative 1/3. Either way, see, same answer. Don't matter. All right, number 26. We got 1 3 here. We got how many 3's here? This many, 2. So then we got 3 to the third power. I feel like I've seen that before. Did I see that before? I don't know. All right, let's try number 27. How many n's do we have on top? We have 4. How many on the bottom? 1. How many can we cancel out? 1. So how many do we have left? That many. 3 on top, right? So it's just going to be n to the third power. That's it. Ooh, look at this one. We got b squared and b squared. So we got 2b squares, right? So we could actually just, ooh, I didn't mean to cancel like all of that. Get canceled. This is, see, we were first. Math, we're at the cutting edge. We were first with all these things, right? We're canceling things out. But this is like the nice way, right? This is, better. Don't listen to me. Okay, so then what do we have left? It's just a 2. B, where did the B go? Both of them canceled out, so we got nothing. Okay. All right, so number 29. So we got, okay, this big 3 here. There's nothing to cancel out, so I'm just going to write that down. And then how many B's do we have? We got 3 B's on top, 1 B on the bottom. How many can we cancel out? 1. So we got 2 on the top. So we're going to be like B squared. All right. So again, you don't need to write it all out like we did for 25 or like how we did for 21. If you can visualize it in your head, you can just show me the answer. That's fine. Okay. But usually when I see it, I can tell. I'm like, oh, okay, this person gets it or not. All right. Let's take a look. If you don't know how I know, become a math teacher. And then you'll be like, oh, you do know. Okay, so the next one right here, 3m squared. Okay, this is the part, most people get this one wrong because they'll be like, ooh, 3m squared, that's it. So they'll be like, oh, 3m squared. No, this is no good. Okay, so I'm gonna be like, I'm gonna take that back. All right, so here we go. What does this mean? We're gonna go back to what does this mean? It means 3m times 3m. That's what this squared means, right? We're multiplying whatever's inside the parentheses 2 times. Okay, so we got 2 times right here. So then what do we have? 3 times 3, which is 9. M times m, which is m squared. See what the difference was? Yes, it was still m squared, but most people forget to square that. And some of you guys may be like, but Miss Lee, didn't you talk about like the exponents and all that? So yes, if you wrote down as 3 squared times m squared, that's fine. Usually if it's like a number in front of a variable, then we would normally just, multiply it out, like 9m squared. But if you did wrote 3 squared m squared, that's fine too. If you wrote 9m squared, that's okay. I just don't want you to do like the 9 for like the ones where it's just numbers. If it's just numbers, give me the exponent. Okay, going on. Oh, 31. What? Look, it's to the 0 power. What is that going to be? 1. Good job. Okay, again, we're going to do the same thing for this one. We have 2x cubed. How many times? 4 times. So then what do we have for the 2, 4, 6, 8? So we have 8, which means 2 to the 4th power, right? And then x, how many of them do we have? We've got 3 of them here, another 3, another 3, another 3. So it'd be 3 times 4, which is going to be x to the 12th. All right, we're getting there. We are more than halfway through, guys. Good job. You're like, how many problems is that? All right, so number 33. Here we go. Here we have coefficients, so we're going to just multiply them together. -2 times 3 is going to be just -6. We have 2 n's here and another 2 n's here, so how many n's is that all together? 2 and 2, 4. Ta-da! That's it. Again, right here, coefficients, the number in front of the variable, we got 2 times -2, which is -4. And then v, how many v's do we got? I got 3 here and another 3 here, so that's going to be 6 altogether. Okay. Do not multiply the exponents. Go back to think about why we're just adding the exponents, okay? Just think about it, because it's v times v times v times another v times v times v. How many v's are actually multiplying together? 6 v's we're multiplying together. Okay. Okay, again, coefficients multiplying, so that's going to be 4. And we got 3 here, and we got 2 more here, so that's going to be 5 altogether. This is 4n to the 5th power. All right, keep on going. Again, we got some coefficients here, 4 times 4, which is going to be 16. We got v, we got 1 over here, plus 4 more, so altogether that would be 5. That many. All right. So here we go. Again, we got coefficients, 3 times 3, which is 9. We got x times x to the 3rd power, so x altogether we would have 4. All right. Ooh, this will be interesting. 2 times 3, which is 6. R, we got 2 r's here, but how many do we have here? None. Because remember, it's to the 0 power. So how much do we actually have? 2. That's it. Okay, and if you remember, what is r to the 0 power? It's just 1, like the number 1. So it would be like 3 times 1, which is just 3. All right, so now we're on to, we've moved past the exponent properties, and we're going into solving exponential equations. Okay, that did not go the way I want. Like, there we go. Okay, if you take a look at this, okay, we've got exponents, right? And we'll say this again. So do you notice that our bases are the same? So it's 2 and 2, right? If those bases are the same, then what should be the same? Those exponents, the little numbers, those exponents better be the same too. Because if we're saying that these are 2 equal things, then if the bases are equal to each other, then the exponents have to equal each other, or else it just doesn't make sense. Then they're not equal. Okay, so we're going to say, so this exponent of negative 2b has to equal the exponent on the other side, which is 15. Notice I did not write down the base. I didn't write down the base because we're not looking, we already know they're equal to each other. We're just looking at just the exponents. So once you set up the equation, it's just solving for the variable at this point, right? So we're going to isolate the variable. So, and if you don't know how to do that, you really need to like pay attention because you need to know how to do this. This is the basis of all like math stuff, is solving equations. So how do you get rid of the negative 2? Do not say plus 2. Divide. Right? Why are we dividing? Because negative 2 is multiplying with the b. So we're undoing a multiply. So that's going to be, make that green. B is equal to, if you want to just be like negative 15 over 2, because I don't know what that is, you can do that, or on a calculator, or in your brain, and that would be negative 7.5. So if you just say negative 7.5, that's fine. If you said negative 15 over 2, that is okay as well. Either of those two are good answers. Okay, so then right here again, bases, yep, they're the same, which means I know that the exponents have to be the same. So 2n minus 3 is have to equal 3. And then let's solve for it. Here, on the side of n, we only have one n here. So we're going to add 3 here. And then what are we going to do? We're going to have just the 2n here on the left is equal to 3 plus 3, which is 6. And then we have 2 n's is equal to 6, which means one of these n's has to equal what? So n is equal to 3. If you think about it, 2 times 3 will give you that 6, right? See how it makes sense? So n is 3. Done. And we're going to go to, again, the bases 4 and 4 are the same, so I know that these exponents have to be the same. So now here, notice we have x on both sides this time, right? Which means we got to get it on one side. So I notice that there's just a number here. So what I'm going to do is I'm going to get rid of the minus x on the left-hand side so that we will, we can just have this number over here. Okay, so I'm just going to be like, instead of minus x, I'm going to be like plus x. So plus x. What does that help us with? That cancels out. And we get just 2 is equal to negative 3x plus x. Think of it like a plus 1x, right, which would be a negative 2x. See what I'm saying? And then from here, what are we going to do? We're going to, again, divide by negative 2, because negative 2 is multiplying with x. And we get x is equal to, I'm just going to write x on the left. Don't mind. 2 divided by negative 2 is negative 1. All right? So that's how that's going to work. And okay, now here we go. Number 42. 6 is not the same as 36, so they do not have the same base. So we can't just be like, oh, 2x is equal to, oh, if there's no exponent is 1. No, we're not doing that. What we need to do is make the bases the same. So I know that this one is a base of 6. So if I think about it, can I rewrite 36 with a base of 6? 6 to what power will give me 36? It would be like 2. Because what's 6 times 6? 36. So we know 6 to the power of 2 is equal to 36. So instead of writing 36, I took that out and I replaced it with 6 squared. Okay, because I know that 6 squared is the same thing as 36. Okay, now, do I have the same bases now? Yes. And now I can write my equation, right? Let's make that this color. So the exponents now have to be the same. 2x is equal to 2. What do? Divide by 2. And we get x is equal to 2 divided by 2, which is 1. So again, remember the trick is to make sure that it has the same base. Once it has the same base, then we could say the exponents have to be equal to each other. All right, so we're at the last two problems of exponential equations. Okay, again, now we have the same basis as 3. So we're like, okay, 3 minus 2v has to equal 2v minus 3. Okay, let's get the v's on the same side. So I'm going to, I want to just not do, I want some positive numbers here. So I'm going to just add 2v to both sides. And what do I have? Just 3 is equal to 2v plus 2v is 4v minus 3. And then I got just v's on the right here, so I'm going to get rid of this 3 over here by adding 3 on both sides. Oop, that doesn't cancel out. What does it become? A 6 is equal to 4v. And then we're going to just divide both sides by 4. So v is equal to 6 over 4. Or we could just see is just be like 1.5. Technically, if it's 6 over 4, I'd want you to reduce the fraction to 3 over 2. So technically, I wouldn't ding you, but just get used to like simplifying things if you can. Like 6 over 4 is the same thing as 3 over 2, right? Divide both of them by 2. Or if you put in the calculator or you just know in your head, 6 divided by 4 is 1.5. Okay, any of those numbers totally work. Okay, same thing for 44. Ooh, this is 625 is not the same base, obviously, as 5. So let's see if we can get it to be 5. So 5 times what will give me 625? 5 times 5 is 25. 5 times another 5 is 25. So I know 25 times 25 is 625. So that means that's going to use up four fives. Or what you can do is you can be like on your calculator, go 5 times 5 times 5. Count how many 5s you're using to get to 625. And you'll see that you need 4 5s to get to 625. All right, so then from here, now we have the same basis. So now we could use the same, the exponents have to be the same. And now it's just a one-step equation. Divide by -2. What do we have? N is equal to -2. Because 4 divided by -2 is -2. Yay. Okay, last thing that we need to do is exponential functions. From a table, we're going to write the exponential function. So a few things you need to know if you don't know already. So function means it's going to be written in this function form, right? Function notation. Okay, f of x. It doesn't always have to be f of x. Like notice for 46 it's m of x, or it could be g of x. Usually we say f of x because f is for function, so f of x. And then it's going to be a times b to the n, to the x, sorry. So remember, a is going to be our starting amount. So how much do we start out with? That's how much it is. B is our multiplier. What do we keep on multiplying by? Then 2 things that you're going to need to figure out. Those are the only 2 things we need. If we know where we start and how much we're multiplying by, we can figure out the rest of the stuff. All right, so if you look at 45, well, I know we're going to have f of x because you look at this, the y part right here. So it's going to be f of x equals, okay, so my starting point. My starting point is when x is equal to 0. So that's going to be right here at 10. So instead of that, I'm going to do this. I'm going to color coordinate it. Let me try that one more time. Equals, and be like here, because x is 0, it's going to be 10. So then I'm multiplying. What am I multiplying by? Well, it goes 10 to 30, and 30 to 90, and 90 to 270. Like, oh, it's just multiplying by 3 every time, right? Times 3. Right, 10 times 3 is 30, 30 times 3 is 90, 90 times 3 is 270. Ooh, so my multiplier is 3. Okay? And don't forget to the x power, right? That tells us like how many like rounds of things. Remember when we're doing the zombies, that's how many days, right? The x tells us how many days we're like we have gone by. Just keep on multiplying by 3, because this x tells us how many times are we going to have to multiply by 3 to this 10, right? You're going to just keep on doing that. All right, so that's it. You see, just write the function. Don't do anything else, just write the function. All right, number 46. We have here m of x, so we're going to use m of x, because they give us m of x equals, and then our starting number, oh look, it gives it to us at 7. It'll be like 7 times, well, what are we multiplying by? 7 times 14, ooh, times 2, times 2, times 2. Ooh, there we go. So we keep on multiplying by 2. And then we're going to put that to the x power. But don't forget your x. Only time you should not forget your x. All right. Oh, 47. Okay, so there's a problem with 47. Not a problem, like the little thing. Because notice right here, what's the starting point? I don't even know. It doesn't tell me, right? So I know we start out with f of x equals, but we don't have a starting point because we don't have the 0. But I know if I go 1 backwards, I'd get the 0, right? So, okay, so let's see. How much do we have to multiply by? Ooh, 24 to 60? I don't know, right? So this is what you're going to do on your calculator. Because if you're like, I don't really know what that would be. So you can find the multiplier. So the b equals, because remember we said the b was a multiplier, is equal to 60 divided by 24. So remember we multiply to get to 60. So we're just going to reverse it. So 60 divided by 24, that will give us how much we're multiplying by, right? And let me look at my calculator. I'm pretty sure I know, but I just want to make sure. Okay, so we're going to be like, you got your calculator out too? Let's see if you got it too. So we're going to go, nope, not the timer. So 60 divided by 24. And I get 2.5. Do you get 2.5? Yes. So I get 2.5. I get 2.5. So we're going to be like 2.5. I'm going to just check because you know what? Sometimes you need to be safe, right? Just check it one more time. So what I'm going to do is I'm going to do 60 times 2.5. You should do it. Do it. Do it for me. What do you get? 150. Oh, look. It's 150. So I'm like, okay, that looks pretty, that looks good. So I know it's 2.5. It's not an error. It's 2.5. So now we're going to go backwards. So instead of like multiplying by 2.5 to go backwards, we're going to divide by 2.5 because I want to know what was it before I multiplied by 2.5. So here we go. So I'm going to take 24, write down 24 and divide it by 2.5. And I get 9.6. Okay, so my number here is 9.6. That's my starting value. So my starting value is going to be right here, 9.6 right here. So 9.6. And what are we multiplying with? Our multiplier is 2.5. So I'm just going to use parentheses here with 2.5 and to the x power. Okay. Ooh, look at 48. We don't have that either. So there's a couple things that we're going to need to do. First, let's write down what we know. I do know I'm going to start with g of x because it says g of x there equals. Okay, let's see here. I don't know what that is, right? So this is how I'm going to figure. How am I going to figure it out again? Oh yeah, 1960 divided by the previous one, which was 2450. Ooh, notice we're getting smaller and smaller and smaller, right? So we should get a decimal. So we're going to get 1960 divided by 2450. And I get 4/5 or 0.8. Okay. So I know that it's going to be 0.8. I'm going to be multiplying by 0.8 every time. 0.8. Let me just check that one more time, just in case, right? Maybe I put it in wrong. So 1960 times 0.8. And what do I get? 1568. Ooh, look, 1568. The third one is 1568. So now I'm going to go backwards. So I'm going to go back to find out what was it for 0. So at 0, so I'm going to go 2450 divided by, right? Because remember, we multiplied to get to the next one. So divided by 0.8. Ooh, and I get 3062.5. Okay, I don't think you can see that. I'm going to say 3062.5. Okay, that was the first one. Where it is first term, so not first term. Starting amount is 3062.5. What are we multiplying by? 0.8 to the eighth power, to the x power. There we go. That's what it is. All right, last two problems, guys. Good job. We're getting there. All right. Oh, we still don't have this. I know we're going down by how much? Ooh, like 50% every time, right? We're not saying 2 because it's not multiplied by 2. We can't say divide by 2 because we're always multiplying. So what are we going to do? There's 2 ways. You can do your 100 divided by 200, or you could be like, oh, it's just half. So we could be like half multiplied by half, right? Because it's half. Or you could say 0.5. 0.5 is also half. Okay, so then what do we do? Go back, right? What do we do to go back? You got to double it, right? Or divide it by 0.5, and that would be 400. Yay! So we know that we're going to start with h of x, because it says h of x on the table, is equal to our starting amount, which is 400. And then what are we multiplying by? 1/2. So we can just literally write 1/2. Just don't forget to the x power, because that's how many times we're multiplying this 1/2. All right. Okay, last one right here, we got w. So we got w of x is equal to, ooh, this time we have our starting amount, so nothing really to calculate. We got 35. And then what are we multiplying by? 140 divided by 35. 35 times 2 is 70. Another 70 would give me 140. So that's being 4. Multiply by 4. Right? And then 140 times 4 is going to be 560. There we go. What did I forget? Did you see it? Yep, I forgot the x. Don't make sure you're not forgetting the x. All right? And that's the end of the review. Please make sure you review all the things, whatever you have trouble with. Go back, just copy it on another sheet of paper, like the problem, and then just solve it again, right? The more you do that, the better it is for your brain, so you can learn a thing, okay? And like keep it in there. Like it doesn't like get out of your brain. Like you got to keep on doing it until it remembers. All right. Have a good one. Bye. Good luck. Do well.